Hi guys, Sajad Hussain again. I'm going to discuss the detailed design procedure of a 12-story building in I'm going to discuss in detail the design of a 12-story building located in Islamabad. If you refer my previous videos, I prepared two videos in designing this for the designing of the building in Islamabad. I used STAD Pro, but now this time I shall be used ETAB 2017, and I shall check whether it is better to design in ETABS 2017 or it should be designed in STAD Pro. What are the advantages and disadvantages? And especially for the practicing engineers, young practicing engineers, which one should be preferred? Either they should prefer ETABS or they should prefer STAD. So let's start our project. I took this example, that is example number 29.1, design of a 12-story cast-in-place frame shear wall building and its component. This is from PCA notes of 31808. As I explained why I took this example, because this building is designed according to provisions of seismic design category D. It has a dual system, that means in north-south direction it has a shear wall and a special moment frame, and a special moment frame in east-west direction. Let me show you the building. This is the building. There are 7 bays of 26 feet in east-west direction, and in north-south direction the bays are of 22 feet. This building has a height of altogether 148 feet, because the ground floor is 16 feet high, but 11 floors are 12 feet high. Exterior columns are 24 inch by 24 inch, interior column was 30 inch by 30 inch, the beams were 20 by 24, the slab is 8 inch. The shear wall is 18 inch in the web plus a 32 by 32 in boundary elements. Similar building is designed in the PCA notes in ACI 31899. The difference between this building and the previous building which I was discussing, that this building which is designed in ACI 31899, it was designed as per seismic zone 4, and of course seismic source type B, soil profile type SB, and other standard procedures. And in my previous video I explained that if the same building you are designing as per the old code, which is UBC 97 or the Building Code of Pakistan 2007, they are the same codes, so you end up with sections which over stress in as per the new codes. That means that if the same building is designed as ASCE 716 or BCP 2021, then there are few elements, especially the columns, are overstressed. It was obvious in the previous model, or in my previous video. In STAD, when I designed these columns and beams in RCDC, all the beams, they were okay, no issues. But when the columns were checked, then the lower columns that means the columns of ground floor, they were overstressed. And for that, I revised these column dimensions, and then it was okay. So the question is whether ETAB will give the same result or there will be something different. So let us start ETAB. For the beginners, I'll say that if you are using ETAB, it is a very user-friendly and easy software. So we can start with the file, a new model. When you open the new model, then the options given are either you use a saved user default settings, or you use settings from a previous model, or you use built-in settings with. So let us see what are the built-in settings. Display units are US customary, that means feet and inches square, etc. Steel section AISC 14, okay. Steel design code is AISC 360-16, and the concrete design code will be ACI 31814, which is compatible with ASCE 716. So I think this is okay. Our units are US customary, so let's say okay. Then you have to define the grids. Uniform grid spacing, yes, the grids are all uniformly spaced. Number of grids in X direction. As you see, the number of grids in X direction sorry, let me because we have selected the example given in a PCA 3188. So here, as I explained, there are 8 grids, all are 26 feet apart, and in vertical direction there are 4 grids which are 22 feet apart. So we will go to ETABs. Number of grid lines in X direction, there are 8 grid lines. Number of Y grid lines in Y direction, there are 4. Let's add a middle grid. Why, I'll explain later. Spacing in X direction is 26 feet. Spacing in Y direction is no. So what we can do, let's add 2 more grids, that is 7, and instead of 22 we will say 11 and half. Why, I'll explain later. Simple story data. Number of stories are 12. Typical story height is 12 feet. The bottom story height is 16 feet. So the grid information has already been provided, and we will say okay. So there are 3 views, one for 3D, another view is from the top, this is the plan view, and here is the model explorer. This model explorer is very good, and just follow the hierarchy over here, and you will see your structure is defined properly. Now here are the grids. Now we want to modify the grids. What modification? I just want to delete this grid. Also I want to, sorry, no, let me cancel. I have to edit the grids, something wrong. In y direction 11.5, it is not 23, rather 22. So 11, 22, 33, 44, 55 and 66. Okay, now we have to delete the second grid and this grid over here. So let's close the 3D view. So I have to delete grid number 2 and grid number 6. Let's again edit. Grid number 2 is not needed, delete. 3, 4, 5, 6 is not needed. Now I can change the number 1, 2, 3, 4 and 5. So what is the advantage? The advantage is this is the center line in this direction. I don't need a center line in this direction, so I did not add it. Why I added this center line? Because now I am going to introduce the shear wall. So let me define first the shear wall and then we will proceed. Here, after that, we have to define the properties. Properties, first of all, material. The first material here is concrete with 4000 psi, that is okay. This is concrete, that means all these information provided over here is by default, so we will say okay. We are not using A416 grade 270 steel, but here we are using A615 grade 60 steel. Let's see. So these are the rebars, A615 grade 60. All the information is there, so we will leave it as it is for the default values. Then frame sections. As you know, all our concrete beams are 24-inch depth and the width is 20-inch. Beam is made of 4000 psi concrete. Section shape is a concrete rectangular, and here the important thing is modify or section modifier. This is very important. We have to define as per ACI 31814, and its section is let me check. So the section modifier parameters are discussed in section 6.3.1.1, and all these modifiers we have to modify. Now the same thing I have compiled in this MathCAD report, which I have been using for my calculation or definition of the loads, etc. So the section properties modifier, as per section 6.6.3.1 of ACI 3114, the moment of inertia and cross-section area of the member shall be calculated in accordance with the table which is reproduced over here. For the member and condition, the columns moment of inertia should be 0.7 of IG. IG is the gross moment of inertia. For walls, uncracked should be 0.7, cracked should be 0.35. For beams, it should be 0.35. For flat plates and flat slabs, it should be 0.25 IG. But cross-section area shall be 1 G. So that means we have to modify the properties of moment of inertia. So let's modify that one. For beam, the moment of inertia about axis 2, it should be 0.35. Moment of inertia about axis 3, it should also be 0.35. The torsion constant, it should be minimal, negligible, so 0.01. Okay. Similarly, we can define the concrete columns. Now we have two types of columns, one which are internal and the one which are at periphery. So let's see. Exterior columns are 24 by 24, interior columns are 30 by 30. So let's say column interior, these are all 24 by 24, and the section modifier, as I explained, the column should be 0.7. So here torsion is okay, so this should be 0.7 about axis 2, and about axis 3 this should be 0.7. Okay, now I can copy the same thing, add copy of this, but now I can say that this is concrete column, and then it should be out, or exterior, or rather that's a better word, exterior. So I did a mistake. The exterior should be 24 by 24 and interior should be 30 by 30. Okay. So exterior is 24 by 24. All data is okay. Okay. Now I can revise this one. Interior column. These are 30 inch by 30 inch. Now I have to introduce wall section. Here by default we have several types of walls available. As you can see, the second one, it has thicker section at the end, and in middle it is thin. So let us select this one. In our model, the wall is 18 inch in web plus 32 inch by 32 inch. So let's define. The length of this column is, as per the model, 22 feet is here from center to center. But here the total length is, it will be 22 feet plus 32 inch. So here it should be 22, sorry, 22 feet plus 32 inch. Feet plus 32 inch. What happened? Plus 32 inch. Something wrong. So we should do like that, 22 feet plus 32 inch, so it will be 24.66. that is okay. (22 plus 32 divided by 12). Now length L1 is this, which is 32 inch. L2 the same, (32 inch divided by 12). Thickness, here the thickness is 12 inch. Actually this is not 12, this is 18, so that means 1.5 feet. Here it is 32, we can modify directly, 32. So we have defined the wall section. Okay, now the angle of rotation is 90 degrees, And now we can place the column over here, and sorry, the shear wall here and here. It's done now. If we want to see in 3D, we will see in 3D. So the shear wall is perfectly defined. Now we have to select all stories. Now we can define the columns and beams, etc. Now we can define column. First, let's define the exterior column. Its moment releases, it is a continuous column. So let's define here, here. All these columns are exterior columns. So we are defining over here. Something wrong. Yeah, that column was by mistake placed over there, which we can delete. So this is not here, we can delete. Fine. So all the exterior columns are defined. Similarly, we can define the interior column. Select interior column. 1, 2, 3, 4, 5, 6, 7, and 8. Now, after defining interior columns, we can define the beams. Concrete beam. Okay. Now we can select like this. We can select like this. We can select like this, and we can select over here. We can select over here, and we can select over here. We can select these beams which are in north-south direction, or so all the beams are defined. Let's have a 3D look. Fine. Let's go to the plan view. All stories are selected over here. Be careful that all stories should be selected. Now we have to define slab. Let's define slab. Slab section. We'll see what the properties are provided here in slab. So let's say slab 8 inch. The thickness of the slab is 8 inch. That's okay. The material of the slab is 4000 psi concrete. It should be treated as thin. Fine. Now here is one trick. If I select from this point to, that means top left corner to bottom right corner, the all slabs here will be defined internally. But we know that the slabs are flush with column. That means the slab has an offset of um, 12 inch, because this column is 24 inch. All the peripheral column are 24 inch, so that means the slab is offset by 12 inch. So let's define slab. The slab 8 inch, it should be offset by 12 inch over here and 12 inch by here, and now we can select like this. Sorry, something wrong. Edit, undo. All the units are feet over here, so it should be only 1 feet. It should be 1 feet only. Now we can define these slabs. Oh, still there is something wrong. We will edit, offset, it should be 12 inch over here. Okay, so first we have to define this slab. We will define this slab from here to here, and then we will select by object type, let's select all the floors, and then we will edit shell, offset should be 12 inch, apply. Now this is the correct procedure. Now you can see that the slab is extended by 12 inch in all direction, and now the slab is flush with the faces of the column. All the corners are there. So this is the right procedure. Let's save the model. So I can say that it should be a 12-story building designed as per ASCE 7 and BCP-2021. Yes. Now let's see the 3D model. Oh, one more is selected. This should not be selected. Okay, so the slab is selected now, and I should delete this slab. Fine, let's save the model. See 3D. Oh, by mistake I deleted all the slabs. Anyway, plan 12-story, all the similar stories, and let's define the slab. Now it's very quick. Let's have a look. Yes, that's fine. And now we can edit, select the slab, edit, edit shell. Okay, so sorry, I did a mistake. Now all the slabs are perfectly designed, so let me save the model. So far what I did, I completed the model. I defined the slab, I defined the column sections, I defined the beams, I defined the shear wall. I will stop my video now because then it will be too long, and in second video I'll explain how to add the loads. So for that time, just wait for the time when I can add the second video that will explain how to define all the loads, the dead load, the live load, wind load, seismic, everything. So I should stop now? Okay, goodbye. Let me finish this now. Thanks a lot.